I'm good. Now it's time for the best presentation of the day. Practices, that is. Like Scott said, my name is Elizabeth Halash. Been on the AppLink team for over 3.5 years now. Done everything from head unit development, working with app partners to get them out the door. Done a little bit on our SDK as well. So I really have run the gamut when it comes to AppLink, which is why I'll be talking about best practices today. Actually, before I get into that, Anu wanted a count of how many additional people may be joining the hack today. So just by a show of hands, anybody who's going to be hanging around to do some hacking with us, keep them up. Anu, let me know when you've got a count. Are you good? All right, thank you. Grab my clicker. Okay, first thing, blank slide. This is what I want you to think about when designing your app to work in the car. How would you use it if you couldn't look at it? Because that's how most drivers use AppLink apps. It's really the first mistake developers make when porting their apps to the car, is that they automatically just throw the metadata they have up there, their same menu structure, without really thinking about how it's being used while you're driving. And that usually leads to problems in app reworks. So it's best to take a little time and think about what's actually going on there, which is that you don't have a user's full focus like you do when you're in the palm of their hand, right? An app in your hand you can look at, you can go through menus, you can read help and tips, things like this. You can't do that when you're in the car. Because in the car, driving is the #1 task. And any app usage, whether it's music, even navigation, is going to be secondary. So you want to make sure that you have an easy and intuitive integration. And Ford comes in with AppLink to try to help with that. We provide a couple things to apps to use in the car. First is static buttons, what I'm going to call either hard buttons on the steering wheel, hard buttons on the center stack, things like play, pause, seek buttons, preset buttons in the car. Then we also have something called soft buttons. We call them soft because even though they may be actual tactile buttons or hard buttons in the car, apps can write text or icons and decide what functions those buttons have. And finally, and most importantly, is voice control. This is something that's really mostly foreign to new apps, new app developers when it comes to the car. But it's really important to make sure you have good voice integration along with your display to make the apps easiest to use while driving. A couple other things I'll talk about in this presentation. Being able to detect different displays. I know there were some questions about this from the last presentation. Performance in the vehicle, how to best kind of initialize your app, how to start right away, how to react to user input. Using display versus voice, when to use either, when to use both at times. How to find and start AppLink apps. And then finally, global considerations like language. Sync is available in 19 languages. A lot of our vehicles come with the ability to have the user change between languages as they want to. So apps need to be able to handle those different scenarios. First thing, I think Marcos touched on this a little bit, how you get button notifications back from the car. It's via the on button press notification. Fairly simple, straightforward. You'll get this no matter what button is pressed, whether it's a soft button, a hard button, on a touchscreen head unit. But there's different modes and different types. It can be a long or short press, and you can also have a button down as well as a button up notification. And these can be combined for different use cases. Using the seek button example, obviously a short, quick press will likely jump to the next song, next station if you're a music type app. Now if you use the button down along with the long press, then you might want to do a fast forward implementation for that specific use case. Talking about preset buttons, a lot of apps use these similar to how they're used with the radio. So a long press will save whatever is currently playing to that button. Short press brings it back up. Different vehicles have different number of presets. Some have 0 through 6, some have 0 through 9, and you'll get those back in the register app interface, what is available and what isn't there. There's also some on-demand RPCs you can use to ask for which buttons are available as well. You'll find those in the SDK. And then finally, you can decide whether or not you want to receive button notifications with the proxy.subscribe button. And that basically says, these are the notifications I want to get from the car when a user presses them. And if something isn't there, sync returns not supported. Pretty simple. Talking about soft buttons, the different implementations we may see going forward. Currently in the focus, we have what's on the left screen there. Apps are able to write any text they want to those buttons. This is highly encouraged to use since it's top menu, top level. It's an easy button press away to get a function really easy for the user to use. We also have the ability to do icons in those buttons as well. I mentioned you can have both static and dynamic buttons. Again, this will depend on what head unit you're currently connected to. The difference between static and dynamic is that some are built in. So for this display on the left, you can only use icons that are already built into the system, and you call them up just with an ID. For going forward, some more richer displays, touchscreen displays, you'll be able to actually send your own icon, whatever you want it to be, and have that show up in a soft button. And that's the dynamic version. As you can see here, this is just an example of the 4 buttons you see on the left. They may, the left screen, they may show up on the column on the right on a different head unit, but it's likely we'll try to keep those front and center so that the operation can be the same. You don't always have to have a different app setup depending on which head unit you're connected to. All right, using voice. Next couple slides talk about this because it's a big one. So first, just describing how voice works on sync. So what an app needs to do, usually this happens right when it starts up, is that it sends the commands it wants sync to recognize. And it sends those commands in either just a text string, or you can use phonemes, which is basically sounds, so read versus read. And what sync does is it takes that string of text and makes a voice grammar for it. And so from there, whenever the user says a command, sync will check that utterance against a list of already built-in voice grammars and try to find a match. If a match is found, an app will get a notification with the OnCommand RPC with a command ID, which is basically a number associating the voice command with one of those text strings you sent previously. If a command is not as certain, sync isn't sure, sometimes it presents a n-best list to a user, so it makes them choose between maybe 4 options, thinks are close to what they said. Again, this is happening totally outside the app. Sync is doing this all on behalf of the app. And then finally, if there's no match at all, sync will just ask the user again, please say the command. Last thing there was if sync does recognize the command, on our newer systems it will play it back. So if you say command like Michigan, sync will come back and say, the positive chime, Michigan, and then the app will get the notification that command was said. One thing to keep in mind is that there is already a pretty long list of built-in commands on sync that an app can't reuse. If an app tries to reuse them, it'll just get rejected, and an app will never get a notification those commands are said by a user. So things like help, exit, and cancel can't be reused by an app. However, it's not that an app can't utilize these commands. Sync just kind of helps out a little bit. So for example, if a user says Pandora exit, or exit Pandora, Sync will close out the app, it'll send an HMI status of none to the app, and then revert back to a different audio source. So the command still works on Sync, it's just the app doesn't really have to take care about how it will work. For the app name help scenario, the app does have the ability to tell Sync what should be said in that scenario. So if I say Pandora help, for example, Pandora does populate this command. It says something like, you can say any of your stations, you can say list my stations, you can say thumbs up or down if you like what you're currently listening to. And that's really what we advise apps to do, because the other option is letting Sync take care of this for you. What Sync will do is just take the first couple voice grammars that you loaded onto the system and just list them out. So in the Pandora example, it would be something like, you can say PlayStation Rock and PlayStation Summer Music and PlayStation on for maybe 5 stations, and that's it. So it's not the worst case, but it may not get to all the commands you really want the user to know about in that help prompt. Then the question becomes, what commands do I load? I have an app, I have a menu structure. How do I port that into the car? How do I make it work with voice? So there's a couple of kind of question and answers that may help you kind of guide you through this process. First question, what are the major features and functions of my app? So thinking about things a user would use most, even outside or inside the car. You'd want to load these as the top level voice grammars of your in-app experience. And so what that means is that when the app is in full, is currently playing, the user presses the push to talk button and they say something like PlayStation Rock, it will work. You don't have to have a voice tree, you don't have to say the app name first. These top level add commands will simply go to the app without any other interaction needed. Second question, do I use shortcuts or favorites or presets, any type of items like this within my app? These are often best to be mapped to the preset buttons. Some apps automatically map them to the car for the user, so they don't have to set them in the car. Other apps allow a user to set them themselves. It just depends on kind of the way the app is already set up, if they want that to be automatically mapped or not. If you have a longer list of choices or items within an app that's maybe contextual based, it's best to use the Perform Interaction RPC that Heath mentioned a little bit earlier. The way that one works is that you build what we call a choice set. So that choice set can have 100 items, 300 items, whatever it is. For example, one of our apps, TuneIn Radio, builds a choice set of about 250 countries. So when the user says stations by country, the app initiates a perform interaction calling the choice set of countries, and then it allows the user to say one of the names of a country. Now, in that specific voice session, the only things Sync will recognize are the items in that choice set. So what that does is make the voice recognition a little bit better for the user in that scenario. Another thing to consider is possibly concatenating choice sets together. So if you potentially maybe have a list of cities, you could do that by state or by country, whatever it is. And what that means is that if you want to do just the cities in Michigan, you would have a smaller choice set, the loading time would be smaller, as well as the voice recognition would be a bit better since it'd be a smaller choice set. However, if the user says stations in America, you'd be able to put all those together without having to reload each city, and that would also help you avoid duplicate grammars on the system. Final question, if I'm a streaming audio type app, what add command should I use? I put this in here because none of these are built in on the system. However, they can and are free to be used by apps, loaded voice commands. And these are really synonymous with media apps. So if you have a media app, you should probably load these up, just in the case the user says play, that your app reacts to that. All right, talking about the in-vehicle display. So going back to when AppLink was first launched, all we really had was 2 lines of text. It's pretty simple. You had 2 lines, they had 20 characters each. You didn't have too much to deal with, too much to think about. In the Fusion here, we've expanded a little bit. There's the media track, the media clock, as well as the 4 soft buttons there. If you do the up or down arrows, you actually get 2 more lines of text. You can have up to 4 lines. And even going forward on the SDL interface and any future versions, we're going to try to remain template-based. And we do this to try to throw driver distraction out of developers' minds so that they really don't have to worry about it. Forward will take care of things like font size, button size, so apps don't have to worry about that. It makes the validation and approval process a lot quicker and a lot smoother. So as far as things, stuff, what do I put on the display? A lot of it's intuitive. If you're some type of streaming app, you want to put up what's currently playing, providing simple information to the user. What's most important, though, is reacting to the user's input. I'll talk a little bit more about this in a couple slides, I think. But throwing up things like buffering. So if you picture yourself driving down the road, there's a lot of traffic, you're already frustrated, you press the seek button and nothing happens. That delay, that even 2-3 second delay, is magnified when you're in the car and you don't know what's going on. Why isn't the song playing? What's going on? There's metadata on the screen. How come I can't hear it? If you throw up a buffering message, as soon as that button is pressed, it removes a lot of that frustration and makes the app usage a lot smoother. The one requirement we do have that apps can control is that there's no scrolling or flashing text. Pretty obvious, not too hard to avoid that. Finally, here's some sample code of how you can detect which display you're currently connected to. As mentioned before, you can definitely do this to make sure that text fits in the display correctly, to know what soft buttons to throw up there. However, if you want to ignore it, you can. If you send a soft button to a 2-line display that doesn't have them, it'll just get ignored by the system. No harm, no foul. Talking about app performance in vehicle. So as I mentioned, any delay in the car is much more magnified while you're driving than while you're using an app on your phone. So what we suggest is to start with the important things. Button subscriptions, making sure that you react to user input with those subscriptions. Setting up the help prompt, so when the user says app name help, they get some good information. And then starting with the first couple commands, the top level commands that a user is most likely to use as soon as they start up the app. From there, depending on what system you're connected to, the grammars may take a little bit of time to load. So we suggest sending batches of about 5 commands every second or so. That helps the system keep up with what the app is sending and making sure all those commands get loaded. And finally, some kind of disconnect requirements. Again, not hard to avoid, just so you know. Sending too many RPC requests in a small amount of time will disconnect your app. And if you also send requests while you're in that HMI level of none, we also treat that as kind of a bad app scenario, and the app may also get unregistered by the system. I threw this slide in here because it's come up a lot in the past on which RPC to use and when. Alert versus perform interaction. So alerts in general are meant to be what you think they would be. Short, informative messages, very similar to a push notification on your phone. On Sync, you can combine both a TTS, a text-to-speech prompt, along with a display, or do either or in an alert. And these can be dismissed by a user closing it, timeout that the app can also specify between, I think, 5 seconds and 30 seconds, and then also getting input from those soft buttons. So that's usually, you're looking at input of maybe 2 items, maybe 3 at most. For perform interactions, it's usually going to be a longer set of choices. And these are set up to be more of a question and answer session. So these will include an initial prompt, we call it, that the app asks a question to the user. So this is all initiated by the app, such as, please select the name of a state. And then the user can come back and say one of the 50 states in the US, such as Michigan. So a guideline there is if your app requires the user to choose from multiple options, more than 2, you should probably go with the Perform Interaction API. Again, you can get input from an alert, but it should really be simple yes or no, or more info type of input there. Providing feedback in the car. Touched on this a little bit, bringing it back up because it's super important. You want to instantly acknowledge any user input, whether it's a button press, a voice command. You don't want there to be too much delay in what you tell the user. Even if the reaction is, wait, hold on, I'm loading, then so be it, as long as they're not confused as to what's going on. In terms of display versus voice, what we usually suggest is to keep the current modality. So if the user gave a voice command, you confirm or respond again with voice. If the user pressed a button or chose a menu item, you respond with maybe just an alert or updating the display to confirm that prompt or that input there. Sometimes there's exceptions. For example, a music app, if you say a voice command, play station rock, it might be best just to start that station. But in doing so, you're providing feedback. You do want to be a little wary about being too talky. Users get pretty annoyed if the voice on Sync called Samantha gets a bit too talkative in the car. They just want to shut her up. So you want to have a good balance, but that's the basic guidelines we give. One more item about Perform Interaction. You can keep what we call a voice tree going for 3 questions, but that's the limit. So this is an example we give. If you want to start with the country, have the user select a country. Sync will respond, user says USA, Sync responds with USA. Then it's up to the app what to do next. If it wants to ask another question, it fills in the text, please select a state. Starts another voice session, user selects the state Michigan, same thing happens. Sync confirms Michigan, then the app sends the next question, please select a city. Starts up another voice session, then the user chooses a city. Marcos had this almost exact slide up, so I won't get too much into it. Just left it up here because this will definitely be key as we get into more touchscreen implementations of SDL. Being able to see an icon and associate the app in the car with your app on the phone is definitely huge. So you want to be able to send the set app icon RPC almost instantly after registering your app. Last big thing to talk about is different languages of sync. Right now, we're rolling out cars in Europe and China with AppLink 2.0 on them. It'll be on the new Mustang here. And most of our cars, the way they're packaged is with many many languages built into the system. So in North America, for example, I believe it comes with English, but then you can also easily change to Canadian French or Mexican Spanish. And the user can do that anytime. So depending on where your app is offered, maybe only in the US, maybe available in Europe, you have to account for these scenarios. Internally, we had a lot of discussions about, well, what should be the master? Should it be the car? Should it be the app? And ultimately, it became a technical answer. The way language change works on sync is that the user goes into a menu, the sync settings, and they select a different language if they want to. At that point, sync does need to do a small reboot to switch all the language on its system, because it changes not only the display, but also the voice. And so due to that kind of longer change that sync needs, we treat sync as kind of the master in this scenario. So what happens is when an app registers, sync will tell the app, all right, I'm in German. And the app may have registered in English. So at that point, it's up to the app to say, okay, I can support German. I'll change my registration. I'm going to send new commands in German. I'm going to tell sync I'm in German. And we should be good to go. This can happen so fast that really the user doesn't even know it's happening. If they don't start the app before all this change happens, then we're good to go, right? If not, let's say the app doesn't support German, then it's kind of up to the app what it wants to do. Sync will still leave the app in the menu. The user may select it, and sync will say, it'll alert the user and say, oh, this app is in a different language. Voice commands may not be supported. We say voice commands because technically we will still support the characters. So even though sync is in German, the app can still send English text to the screen. And technically it will still work via all the menu and display options. However, a voice command such as Spotify won't necessarily work if the car is in German. We had some fellow engineers in Germany say that sync was pronouncing it, I think it was like Spotify, if sync was in German. And so things may work, they may not. It's definitely an odd scenario. It's probably best to avoid it. However, a user may become comfortable with using that different mixed language scenario. It depends really how different the two languages are. One thing to add here is app name pronunciation. A great example of this is the app Glimpse. On the original version of sync would always pronounce the app Glimpse because it is spelled with a Y. And so we added a new parameter to the register app interface, RPC, for voice command particular recognition. So the app can send the display name as well as the voice recognition name. And so sync will, if you fill out that parameter, sync will treat that as the main voice command as well as the text-to-speech string or phone name to use when either referencing the app in a text-to-speech or looking for the user to say that voice command. All right, some final thoughts. Start simple. Remember that the app usage in a car is secondary, driving is first. So you want your app to be as intuitive as possible. You don't want the user to have to remember too many voice commands. You can assume that they do know the app, that they're regular users. I don't think that's an issue. So if you have a certain type of, if you call them stations or if you call them playlists on Spotify, for example, you can keep that type of terminology the same for sure. But stick with the kind of the big hitters of your app. Also, in terms of consumption and discovery, for the most part, you just want to have the user consume what they've already set up in the app. So you want them to use the playlists that are already set up or the stations they already know. The discovery in terms of like searching for new content or finding new things takes a lot of brain power, let's face it, as well as a lot more interaction with the user, so you want to limit that. There are some intuitive ways of doing this, such as, make a new station by the currently playing track. That's definitely possible and a simple thing to do, but you want to limit that. And again, focus on using voice instead of the display, or possibly use both. One thing to keep in mind is that while we do offer submenus in the car, a lot of times we don't allow access while driving anyway. So you want to make sure that even if you use them, always have a dual command in voice. There's nothing wrong with having 3 different ways of doing the same thing in the car. All right, so to leave you with a quote from our good old founder as we start entering the hack portion of the evening: quality means doing it right when no one is looking. So if you do it right, when it goes through the forward validation process, you probably won't find anything wrong, and you'll be out the door. All right, that's it for me.